Hey guys, this is Professor Broker. This is your first Chapter 13 lecture for Econ 231 titled The Cost of Production, Part 1. Let's get started. Okay, so I want you to do a little brainstorming with me, if you would. You're running a car wash business, okay? What resources are you going to need to run your car wash business? Right, you're going to need some water, right? You're going to need probably some workers. You're going to need some sponges and soap and hoses at the very minimum, right? And some of these are natural resources, some of these are labor resources, some of these are capital resources. So you're going to be pulling these resources together to run your business, right? What kind of costs are you going to have, right? Think about some different costs, right? You're going to have a water bill, probably a utility bill. You're going to have to pay your workers, right? So you're going to have payroll that you're going to have to pay. You might have to rent the land or lease the land, right? You're going to have to pay for materials to come in, soap and different things like that. Okay. Also, think about some business decisions you're going to have to make as a business owner. How many workers are you going to hire? How much output are you going to produce? How long are you going to stay open? Okay, these are decisions you're going to have to make. Some of these big decisions. And the point I want to get across with this little example is that your costs are inextricably linked to your biggest business decisions, right? I mean, thinking about how many workers you're going to hire. Well, how much are you paying them, right? What's your labor cost going to be? Well, your labor costs are going to be directly related to how many workers you hire and what you're paying them per hour or salary. And so, how long are you going to stay open? That's probably going to have a lot to do with various costs, right? How much product are you going to try to produce or things like that? That's probably going to have to do with your cost of materials and things like that. It's definitely going to factor in. And so your costs are very important. And so that's what Chapter 13 is all about, is the economics of the cost of production for business enterprises. So that's what we're going to talk about. So let's get started. Before we talk about costs, we need to talk about production. Okay, so we're going to talk about something called the production function. A production function is very basic. You can see production function just about anywhere. It's simply a relationship between inputs and outputs. You can have a production function when you're studying for a test, right? And so your input might be the amount of time, right, that you invest maybe working through a problem set or so on, and your output could be, how many problems you get done, right? Or your input could be the amount of time you spend reading a chapter, and then your output could be the score or the number of questions you get right on a quiz or on a test. Okay, that's a production function. It's also true for a business, right? So we're going to look at a specific example, right, of a farmer, right? He's got some land, Farmer Jack. He's growing wheat, so his output is bushels of wheat, and we're only going to focus on one input, and that is labor. He has a decision of how many workers he can hire. Okay, notice we're controlling his land resource, right? We're basically saying he has 5 acres, and that's not changing in this example. Okay, and so the only input changing is the number of workers he's hiring. Okay, so we have a production function. Well, again, we can show a production function with an equation. We can show it with a table of data. We can also graph it. So let's look at a table and our graph. Okay, so notice that on this graph, we have our input on the x-axis and our output on the y-axis. So we have number of workers down here. We have quantity of wheat, bushels of wheat up here. Okay, and if he hires no workers, then he's going to get no wheat. Okay, so 0 and 0. Notice the green point right there. If he hires the first worker, we say that he, according to his production function, he produces 1,000 bushels of wheat. If he hires 2 workers, 1,800. 3 workers, 2,400. 4 workers, 2,800. 5 workers, 3,000. Okay, so these are our production points. Now, if we kind of connect those dots, we have a graphical representation of our production function, right, for Farmer Jack. Now, I want you to notice the shape of our production function. What kind of shape do you see? Well, first of all, it's increasing, right? The more workers he hires, the more bushels of wheat he can harvest. Okay, that seems intuitive. What might not be intuitive is that, first of all, is this a linear line? And it's obviously not, right? And so that means that as we hire additional workers, we are increasing our quantity of output, but not at a constant rate, because this is not a linear line. It's not a linear function. So then we have to ask ourselves, is it increasing at an increasing rate, or is it increasing at a decreasing rate? Okay, well, if it was increasing at an increasing rate, it would be sloped upwards, right? And it's not. It's becoming flatter. The more workers he hires, our function is becoming flatter up here at top, which means the more workers he hires, he's getting more output, but at a decreasing rate. Okay? That's important because most production functions are like that, and we're going to explain why here in just a second. Okay? Now, to explain why, I showed this table because we're going to be filling in this table here in just a second. So you see here, right, the number of workers, okay, and the quantity of output. So as we move through this lecture and the next lecture, we will fill in this table of data, okay? So the next concept we need to talk about to be able to understand the shape of the production function is marginal product. Marginal product simply means extra product. Remember the word marginal simply means extra. So the extra amount of output that we get from one additional unit of input is our marginal product. In this case, okay, we're simply looking at our input is a change in labor. So in Farmer Jack's case, his marginal product could be represented as the change in output he gets from hiring an additional worker. Okay. Notationally, we might refer to this as delta, which means change in output or quantity, divided by change in labor. So as he hires one more worker in the denominator, how much does output increase by in the numerator? Okay, so let's take a look at it. Okay, so in order to figure this out, first, he starts out hiring nobody, right, and he gets no output. And as he hires the first worker, right, so we have a change of one worker here. How much does output change by? Well, it goes from 0 to 1,000. The difference there is obviously 1,000. Okay, and so that's the marginal product, specifically of labor, the marginal product of labor for hiring the first worker. What is the marginal product of hiring the second worker? Okay, it's not 1,800. It's the difference between 1,000 and 1,800, which would be 800. Okay, and then for the third worker, it's the difference between 2,400 and 1,800, which is 600. Okay, hiring the fourth worker increases output by an additional 400, and hiring the fifth worker increases output by an additional 200. Okay? Now, what do you notice is true about as we add more workers, what is happening to the marginal product of labor? Obviously, it's decreasing, okay? And because it's decreasing, that's what gives us the shape of this production function, okay? Notice that we had the corresponding slopes of the line over here as we're moving forward. The marginal product essentially is the slope of the line, and the slope, right, is becoming flatter and flatter and flatter, okay? Smaller and smaller and smaller, in other words. And that's it's the marginal product that's driving that, okay? So let's go ahead and input the marginal product numbers into our table. Remember, the first worker netted Farmer Jack 1,000 bushels. The second worker netted him 800. The third worker 600. The fourth worker 400. The fifth worker only 200 bushels. Now, I also want to make the point that, it looks like the fifth worker is pretty worthless, right? I mean, the fifth worker doesn't add very much compared to the first worker. So you might conclude that the fifth worker is maybe lazier, doesn't work as hard, or what have you. That doesn't have to be true. The fifth worker could actually have a harder work ethic than the first worker. This relationship is true not because of the work ethic of these individual workers per se, but simply because, and we'll explain this here more on the next slide, but because there's fewer and fewer capital resources to use in the production process. And so, as you hire more and more of the same input, in this case labor, you could have very hard workers at the tail end, your fourth and fifth and sixth and 10th workers, but there's just simply not as much for them to do in the production process. And that's what drives these decreasing numbers. Okay? Now, I already said marginal product equals the slope of the production function. Okay, notice it diminishes. Okay, why does it diminish? Okay, and the fact that marginal product diminishes is why the production function has a flatter shape to it. Okay, but why does it diminish? We call this diminishing marginal product. Okay, and this, think about, Farmer Jack. What's he's doing? He might have some tools that he's using. He probably has a limited number, but specifically think about the land, right? He's only got 5 acres of land. So, we kind of see it with the first 5 workers, but imagine that he hires 10 workers or 20 workers or 1,000 workers. if he hires 1,000 workers, does that necessarily mean he's going to continue to increase production? Of course not, because he's only got 5 acres of land with which to plant wheat. And at some point, he will have planted, all the wheat that you can plant on 5 acres. And so it wouldn't matter how many he could hire 10,000 workers, and it still wouldn't increase his production. Okay? And that's the whole point. And that's why you get diminishing marginal product, is because as you hire more and more of the same input without corresponding increases in other inputs like capital or land, you're going to get diminishing returns from those workers. Okay, I like to think of this example. I used to work at a movie theater, and when I worked at the movie theater, sometimes I would work concessions, right? And there'd be times where, it wouldn't be very busy, right? And so there might only be one person, maybe just me, standing behind the counter serving customers. But then maybe there'd be a rush of people that come in, and the lobby is full of people, right? And we need more workers. Well, if the lobby is full of people and the line's back to the door, and I'm the only concession worker at the time, adding another concession worker, right, would definitely increase productivity. There's no doubt about it, right? Adding the second worker would probably increase productivity. Maybe even a third and fourth worker could increase productivity. We could get more customers through the line quicker, right? As we added the first, second, third, maybe and fourth workers. But there came a point, because there were only 5, I believe there were 5 checkout lines. There was only 1 popcorn maker. There was only a couple drink dispensers, right? There was a limited number of space and machinery and cash registers, right, that we had behind the counter. And so at some point, it was going to be true that if, for example, if we tried to bring in a 20th or a 30th or a 50th concession worker, that extra worker could have been a very hard worker, but they weren't going to help us at all. In fact, they could have made us less productive, because they would have been bumping into us, knocking over the popcorn, knocking over the concession, knocking over the register, because there wasn't enough space. Okay? And so this illustrates the sort of the underlying reasoning behind the diminishing marginal product. When you have a fixed amount of space or fixed capital resources like a cash register or a popcorn maker, right, you're only going to get so much productivity out of those resources as you add workers, right? And at some point, the extra output's going to be diminishing. We call this the law of diminishing marginal product or diminishing marginal productivity. Okay? Now, why is marginal product important? Well, because remember, one of our principles was rational people think at the margin. Okay? So Farmer Jack is probably going to be making decisions about hiring workers, how much to produce at the margin. In other words, he might, when determining how many workers to hire, right? He might already have 2 workers. So his decision about hiring a third worker is going to look like, how much is the extra cost? How much is it going to cost me extra to hire a third additional worker? And what will be the extra benefit of hiring that third worker, right? Well, the extra benefit of hiring the third worker will not be the total output, but simply it will be the extra output or the marginal product of hiring that third worker. Okay? And so that's what we want to look at next. So let me just ask you, how many workers, right, should Farmer Jack hire? Or would it be rational for him to hire? Would it be profit maximizing for him to hire if he can get $5 per bushel of wheat and if he pays each worker $2,000? Okay, well, in order to, analyze this question, we not only need to look at the extra output, but we need to look at the value of that extra output. In other words, the first worker adds 1,000 bushels of wheat for Farmer Jack of benefit. But what is that 1,000 bushels of wheat worth? Well, it would be worth 1,000 bushels times the $5 per bushel that Farmer Jack can get. In other words, that first worker would be adding $5,000 worth of benefit for Farmer Jack. Okay? Now let's go ahead and calculate what we're going to call the value of the marginal product, okay, of labor for each of these extra workers. So the first worker, right, would add $5,000 of benefit, the 1,000 bushels, right, times the $5 per bushel that I told you in the problem, gives us 5,000, right? Then the 800 bushels, right, that the second worker adds, okay, as their marginal product times 5 would be 4,000. The third worker, 600 times $5 would be 3,000. The fourth worker, 400 bushels times 5 would be 2,000. The fifth worker, 200 times 5 would be just 1,000. Okay, now again, he's paying his farmers or his helpers, his workers, $2,000 per month, okay, or for this job. So the question is, what would be the rational number of workers to hire? Well, let's look at it this way. Let's think about it at the margin. Okay, Farmer Jack, when deciding to hire the first worker, would look at this first worker is going to create $5,000 worth of benefit for me and only cost me $2,000. So should he hire the first worker? Absolutely, $5,000 of benefit is greater than $2,000 of cost. Okay, now let's look at the second worker. The second worker would add $4,000 of benefit for Farmer Jack and only cost him $2,000. Should he hire the second worker? Absolutely. It would be rational to hire the second worker. What about the third worker? The third worker adds $3,000 of benefit and only costs him $2,000 of wage. The third worker is beneficial. Now we get to the fourth worker, right? And the fourth worker would generate exactly the same number of benefits, $2,000, as it would cost him $2,000. And so we would say that he's indifferent at the fourth worker, but we're going to go ahead and say that he's going to try to maximize his output. So it would be rational for him to hire 4 workers, right? Hiring the fourth worker would definitely not decrease his profit, right? And it would maximize his output. Do you notice that hiring the fifth worker would actually be counterproductive, at least in terms of maximizing profits, because the fifth worker would only add $1,000 worth of benefits for Farmer Jack, okay, while costing him $2,000. And so he would actually be losing money by hiring the fifth worker. Now, in the real world, he might want to do that. He might want to hire the fifth worker. Maybe it's a buddy of his or whatever, and he's willing to accept lower profits. But rationally speaking, just from a strictly rational perspective, the fifth worker would decrease his profits. So it wouldn't be rational for him to hire him, okay, or her. So 4 workers, right? But now let's change the problem a little bit, okay? Let's again think at the margin. What if the wage arbitrarily increases to $3,000, okay? Just arbitrarily. Maybe there's a law passed that says that Farmer Jack has to pay his workers $3,000 instead of $2,000, okay? How could that potentially impact his hiring decision? Now, of course, the workers who get the higher wage are going to be better off. That's no doubt, okay? But how would it impact his marginal hiring decision? Well, let's take a look. Let's do the same analysis. Farmer Jack, when deciding to hire the first worker, would still compare $5,000 benefit to now $3,000 of wage cost. It would still be beneficial to hire the first worker. Okay, but what about the second worker? Yeah, the second worker would still be beneficial because $4,000 is greater than $3,000 wage, so the second worker would still be beneficial. The third worker would create exactly the same number of benefits, $3,000, as the wage cost. Okay, so Farmer Jack would be indifferent to hiring the third worker. He'd probably go ahead and do it to maximize his output. But now the fourth worker that he hired before at the lower wage now only generates $2,000 of benefit, but now would be required to make $3,000 of wage, which would mean hiring the fourth worker now would actually decrease Farmer Jack's profit. So again, if he's rational, just looking at it from a strictly rational numerical perspective, Farmer Jack should only hire 3 workers at the higher wage. He would actually reduce the number of workers he hires. Actually, it would also reduce his level of output. Okay, again, thinking about this at the margin, thinking about the costs and benefits of this hiring decision. Okay, now you might say, well, gosh, if just arbitrarily maybe forcing, Farmer Jack to increase the wages of his workers, if that decreases output and decreases the number of workers he hires, then what economically could induce Farmer Jack to increase the pay of his workers? Well, a number of things. So, for example, how did we calculate these benefits, right? Well, this value of the marginal product was calculated as the marginal product times the price that Farmer Jack got. So imagine if the price of wheat went up. Okay, there could be forces that would increase maybe the demand for wheat or so on, that would increase the market price for wheat. Well, that would increase these numbers. And as these numbers increase, right, then that could give Farmer Jack an incentive and also induce him to, and he might have to compete in order to attract workers to his operation from other competition, he might have to offer them higher wages. Another way that he could just, he might want to or need to pay his workers more is if we can increase these numbers somehow. So maybe Farmer Jack buys more land. Maybe Farmer Jack buys more specialized equipment that enables his workers to generate more bushels of wheat. Maybe some other technology, maybe some special seeds or something like that enables his workers to become more productive and thus more valuable to him, could increase these numbers, the benefit to him, which could induce him also to increase their pay. But the pay, but him increasing their pay for these reasons would be directly linked to their productivity. Okay, and in the long run, it's actually pretty difficult to divorce the concept of rising income and wages from the concept of rising productivity. They typically go hand in hand. Okay?